What's up, guys? So my name is Rico. I work at Decentral, and we do consulting for blockchain companies. Okay, let's start. All right, so the price of Ether has dropped a lot this past year, right? Unfortunately, I know because I've been hodling since December. But, the good news is that its technology and its ecosystem continues to evolve. And today I'm going to go through some of the most important things that you should know when dealing with smart contracts. Okay. So smart contract programming is not regular software engineering. It requires a different mindset. How do I go back? Yes. Yeah, because with, what is it? Oh, not this one. Oh, okay. Because with smart contracts, you're dealing with people's currency that can't be reverted. So one mistake can cost millions of dollars. Like some examples of this are the DAO hack and the parity multi-sig wallet. So it's not enough to protect against known attacks. You must adapt like the way you write software to account for these risks. So prepare to fail early and fast. Here are some techniques that will help you prepare for failure. So make sure your contracts are pausable. You never know when you might run into an issue, like if you encounter a bug during an ICO. Use state variables to limit the amount of Ether you put at risk in your contracts, and have a way to upgrade your contracts. So one way to upgrade your contracts is to use a registry contract, which holds the address of your contract's latest version. Okay. Keep contracts simple. What that means is make sure your contract logic is simple, easy to read, and functions are small. And always use already written tools and software whenever you can, because they will be battle tested and proven to work. An example, don't write your own random number generator. Instead, use an existing one. And OpenZeppelin is the largest repository of standard smart contracts. And last, so you don't need to put everything on the blockchain. In fact, the less the better, because you save money from gas costs, transactions, and storage. Roll out carefully. It's always better to catch a bug before a full production release. So make sure to test your contracts thoroughly until you're sure that it's safe to deploy. And last, keep blockchain properties in mind, such as gas costs and the block gas limit. Remember that all your data on the blockchain is public, even if you make it private, and that anyone can call your public and external functions, which may be called maliciously. Okay, now I'm going to go over some of the best tools and the workflow you should do when dealing with smart contracts. So the two IDEs with Solidity support are Visual Studio Code and Atom. I personally use VS Code. Make sure you install a Solidity linter extension, because it will warn you and give errors if you're not following best practices. And it will even warn you if you introduce a security bug in your code. Remix is a browser IDE that's best used if you need to do something fast on the fly, like you need to deploy a contract and just manually test it really fast. And it's also really good if you're just starting out learning Solidity. Okay, truffle, like the type of chocolate, is the most popular development framework for Ethereum. I always use Truffle when I'm dealing with smart contracts. It makes my life easier. It'll make your life easier. And it includes boilerplate code, a folder structure for you to follow, deployment and testing environments. Okay, so OpenZeppelin is a library for writing secure smart contracts. It's been well tested by the community, but nothing is 100% safe, right? So make sure to also thoroughly test and audit your own code. I always reuse OpenZeppelin smart contracts when I can. Ganache, which is also like chocolate. There's like a theme that they're trying to do. It's a personal blockchain for Ethereum that runs on your computer. So I use Ganache to deploy and test locally before moving on to a public environment. Okay, so public test networks. There are 3 in Ethereum. Ropsten, which uses proof of work and is supported by Geth and Parity. Rinkeby, which uses proof of authority and is supported only by Geth. And Kovan, which uses proof of authority and is only supported by Parity. So instead of using Geth or Parity, use Infura. So back when I was trying to get, I was starting with smart contracts and I was trying to get Geth working, it was really difficult. I went through like a dozen Stack Overflow posts and GitHub issues, but it wasn't until later that I found Infura, so Infura runs an Ethereum node for you without you having to download anything. So the workflow here for testnet is to deploy to the testnet and then test interacting with your contract in your dApp. You can also use Etherscan to verify your transactions and your code. Okay, the final step is to deploy to mainnet. So you might be asking, why go through all of this, right? Well, because if you don't, you can risk losing a lot of money. So many companies do an audit and even multiple audits before they deploy to mainnet, because once deployed, there's no changing it. And so like contracts should go through like a lot of rigorous testing before substantial money is put at risk. Think of it like this. Would you rather lose a lot of money because a hacker found a bug in your contract, or have spent that money on an audit which could have found that bug, right? So at minimum, you should follow these procedures and checklists when dealing with smart contracts, because the cost of failure can be high. Okay, now I'm going to go over some key patterns and security bugs that you should know. So some of these were real mistakes that cost real money. Okay, overflows and underflows. An overflow is when a number gets incremented above its maximum value. Solidity can only handle up to 256-bit numbers. So if you incrementing by 1, like in the overflow function, would result onto 0. And an underflow is when an unsigned integer 0 is decremented, which would result in the maximum value. So the solution to this is to use OpenZeppelin's SafeMath library, which checks the resulting number for overflows and underflows. Okay, race conditions. So calling external functions can be dangerous because you give control over to that contract, which can make changes to your data that you weren't expecting. The DAO is an example of this class of bug, which led to 3.6 million Ether loss. The first version of this bug is reentrancy, which is when a function is repeatedly called before the first invocation is finished. So here's an example. An attacker could call withdraw balance, and you see how the user's balance is not set to 0 until the end of the function. They can repeatedly call withdraw balance, and the second and later invocations will still succeed, allowing the attacker to withdraw the balance over and over again. Cross-function race conditions. An attacker may also be able to do a similar attack using two functions that share the same state. So in this example, it also has the withdraw balance function from earlier, but it also has a transfer function. So an attacker calls withdraw balance, and while they're executing withdraw balance, they call transfer, and because, again, the balance is not set to 0 until the end, the attacker is able to transfer the tokens even though they already received the withdrawal. Okay, so how can you avoid these? Use the checks effects interactions pattern, which will prevent race conditions and also protect against many other security issues. So always first perform checks such as who called the function, or does the user have tokens? And then second, if all of the checks pass, then you can make changes to your state. And interactions with other contracts should always be last. Okay. Transaction ordering dependence is another type of bug. So the before examples were cases where involving a single transaction, but because the order of transactions within a block can be manipulated, an attacker may also do a similar attack that involves multiple transactions. An example of this would be like a decentralized market where a transaction for an order gets placed, but before the order is placed, someone sees that in the blockchain and makes a market order. If you absolutely must go through multiple transactions, when you loop through over an array of unknown size and you think it will take multiple transactions across multiple blocks, you use an index, like in this example. So when you use the index, it keeps track of the last user that you stopped at in the previous transaction, and then you can resume using that index. You have to make sure that other transactions that are processed while you're waiting for the next iteration of this function, nothing bad happens. So only use this pattern if absolutely necessary. Okay, so favor pull over push payments. The problem with push payments is that the push function can stop working because of a denial of service attack, like in this auction contract. And also, push functions can stop working if you loop over an array while sending to users. You can run out of gas. So it's better to use a pull payment system, like in this example, where you allow users to withdraw and like to pull their funds instead of pushing funds to them. All right, so here's one that you might not know, and it's forcing Ether to a contract. So Solidity self-destruct does two things. It renders the contract useless by deleting all of the bytecode at that address, and also sends all of the funds to a target address. The special case here is that if the receiving address is a contract, the fallback function doesn't get executed. So take a look at this contract, which uses its balance as a check. So an attacker can create a contract and put some ETH in it, and then self-destruct it with this force Ether contract as the target address. And from that, normally this contract would throw if any Ether is received in the fallback function. But because the balance is now like greater than 0, the attacker is able to bypass the required statement in the only non-zero balance function. So solution: never have a condition that checks the balance of a contract. And also, don't assume that a contract is created with 0 balance. Okay. So like for further learning, I have some really good resources. So Crypto Zombies was one of the best Solidity tutorials that I went through. I also have a complete tutorial on getting started with your dev environment and smart contracts on Medium. To go more in depth with smart contract security, Consensus has a really good article, and then always reuse Open Zeppelin contracts when you can. All right. Any questions?